Hi everyone, welcome to part 3 of this video where we are discussing about the approach of answering question that asks you to plan an experiment in paper 6 IGCSE alternative to practicals. So in the first two videos we discussed about the subheadings that are about the variables and then the apparatus, right? The second video was about the apparatus. So in this last part of the video we are going to discuss about remaining subheadings, which are the method of doing the experiment that you are planning, table where you can collect the data, and analysis where you may represent the data in the form of graph, and then how you can perform the analysis to come to the conclusion. If you remember, I told you about the keyword plan in your question, right? So to come up with a conclusion that matches the aim of the experiment, and then any precautions that you could add for the experiment that you plan, or any additional details can be written in the last subheading, which is precautions and additional details, right? So let's proceed with method for the first question. So you remember we are choosing two papers to discuss, two past year papers. One is Feb March 23, the other one is Feb March 22. So let's discuss the method of my planning. Okay, method of my planning to do this experiment where a student investigates the motion of a ball through the air, and my planning enables the student to investigate how the range of the ball depends on the angle at which it is launched. So what are the apparatus I have? Let's have a quick recap. Which is the dependent variable? The dependent variable is the range of the ball, right? Which is the independent variable? Angle at which it is launched. So you change the angle at which the ball is launched, the range is going to be differ, right? And then what are the control variables here? The ball, diameter of the ball, material of the ball, or mass of the ball, right? Now we also discussed about the apparatus required. What are the additional apparatus required? One is the protractor to measure the angle, because we need to find out when you change the angle. So what is the angle that you fix? You need to measure that, right? So you need protractor, and then to measure the range we need meter rule, right? That's a quick recap. Okay, so how am I going to plan this experiment now? So let's go through this question here. List any additional apparatus needed. Yes, we listed. Explain briefly how to do the experiment. You may add to figure 4.1 if it helps your explanation. So you want to add anything to the picture, you can add. So if you remember, I drew the height of the bottom tip of the channel as h1, and the height of the top tip, the top edge of the channel as h2 from the floor, right? And you can even draw a ball here. You see, you release the ball from this top edge of the channel, which then moves through the slope of the channel and then flies off from the bottom edge of the channel, and then it takes this path below before it reaches the ground here, right? So what is range? Range is the distance that you measure from the tip of the bottom edge of the channel until the ball hits. Remember, ball hits the ground. It is not where the ball stops. Yeah, there is a lot of difference between that. Fine. So this is my range. You may do this measurement. Okay, fine. So I need to briefly explain how I'm going to perform this experiment. And then key variables to keep constant. Yes, already we discussed this. And then draw a table, okay, which we will be doing in a short while. Explain how to use the results to reach conclusion. We will discuss in a short while. Fine. Now let's focus on the method. So how am I going to do this experiment? Like how am I going to suggest the student who is going to perform this experiment? What are the suggestions that I make? First thing is that I want the student to keep the ball at the top edge of the channel. Then drop the ball there, yeah, or just leave the ball from that point of the channel. Then what happens to the ball? The ball moves through the channel, and then it flies off from the bottom edge. But before that, what are we missing? The angle that we need to fix, right? So that must be the first step then, right? So measure the angle, adjust the bottom edge of the channel, this one, adjust the bottom of the edge of the channel and measure the angle that it makes with the horizontal, yeah, using the protractor. So mention that in your method. Otherwise, if you don't give the clear instruction, like, how to measure the angle, or the angle is made between what and what, then the experimenter will get confused, right? Those who do the experiment, the student will get confused. So you need to give a clear cut instruction, but in brief, right? So the first step is adjust the bottom edge of the channel and keep it at an angle with respect to the horizontal, measure the angle using protractor. Now drop the ball at the top edge of the channel, which then moves through the channel and flies off at the bottom edge. And then what happens to the ball? It reaches the ground over there. So here you can use this point. Keep a marker at the point where the ball hits the ground. Then measure the distance between the bottom edge, horizontal distance between the bottom edge of the channel and the marker, right? That's going to be your range. Fine. So after this, what should the experimenter do? Note down these values of angle and range in the table. Then for the same angle, the experiment can be done for the second trial. What is the reason? To avoid any random errors, right? So this has to be mentioned in your answer. So whenever you vary the independent variable to measure the dependent variable, that could be done twice for 2 trials, and then finding the average is the best way to avoid random errors. Yeah. So do the experiment for the second trial, measure R for the second trial and find the average. And then what should you do? Now vary the angle, adjust the channel again, vary the angle, right? Vary the angle so that you can perform the experiment for the second angle, and the range is going to be different this time. And do this also for 2 trials. Like this, you need to have 5 sets of data, right? So this is the method that we are going to follow. You can see this is the method that I have written. So adjust the bottom tip of the flexible channel so that it is bent to some angle theta, and measure it with the protractor. Measure it with the protractor. You need to mention how are we going to measure that. Then select a ball of constant diameter and mass. Leave the ball from the top of the channel. The ball rolls down the channel and flies off from the bottom tip. Fine. You see, I used the bulletins in the form of numbers, right? Why? You will come to know that in a short while. Keep a marker at that point on the ground where the ball hits. Now measure the horizontal distance from the bottom tip of the channel till the point where the ball hits the ground. It's not where the ball stops on the ground, yeah? Using the meter rule. Then note this distance in the table. Now, you see, I repeat from step 2 until step 5 for the second trial, for the same angle, right? So for this purpose only, to mention from which step to which step to repeat again, I use a number bulletin, right? So that's good practice if you do the number bulletins over there. Yeah. Then find the average of R for trials 1 and 2. Now we should repeat the experiment for different angles, right? That is my next point. So vary the angle or change the angle of the flexible channel in steps of every 5 degrees. I am making the making the the experiment. I'm repeating the experiment. Okay. So from step 2 until step 6. So now I complete my table, right? So you need to mention this point also. Repeat the experiment for at least 4 or 5 different sets of angles. Yeah. So this point is very important. And then the flow of your method is also very important. How are you going to measure the dependent and independent variable with what instrument? That is very important. And do it for 2 trials to find the dependent variable, and finding the average is very important key point over there. Now, as I mentioned, we need to collect this data in the table, right? So that's our next question then. So how do I draw the table? Very simple and easy thing. You see, so the table does not need to have value over there, because you are just suggesting the experimenter how to perform the experiment, right? So I have a table where the first column talks about the number of experiments. I'm going to do it for 5 times, right? So I have 5 sets of data here, right? Then comes the independent variable, and then you write the dependent variable. You see how it is helpful if you categorize the independent and dependent variable at the beginning of the experiment to draw this table. Yeah, it's so helpful, right? And remember one thing in the table which I cannot forget is the column headings. Angle theta. This is why I asked you in the first video that while writing the independent variable, you can mention there what is the letter you are going to use to represent the particular quantity. I use theta and then slash degree unit. If any one of, if the unit is not mentioned, then definitely you are going to lose this mark. Yeah. And then range. R, this letter I already I already defined in my first part of the video for range, right? Slash meter. What is M? Meter. So this is the unit for range. And then trial 1, trial 2, and finding the average, right? So this is how I frame my table for the experimenter. All right. So after I collected the data, what should I do? I should analyze and make conclusion, right? So what is the analysis that we are doing here? Comparing the data from this column, angle column, and average column. So from the comparison, we may say how varying the angle of launch affecting the range of the ball, right? So yeah, so this is my conclusion now. So I can add another point also here. Let's say, compare the data in the table. Compare the data in the table to find out how changing angle affects the range. Changing angle of launch. Oh my gosh. Okay, sorry. Changing the angle affects the range. Or you may say that plot a graph. So when you write this step, yeah, you need to be very clear which quantity you want the experimenter to draw on which axis. So always remember, unless otherwise specified in the question, the independent quantity must be always on the x-axis and the dependent quantity must be always on the y-axis. Okay, so which is the independent quantity for us? Angle of launch, including its unit. X-axis, you need to mention this. Which is the dependent quantity? Range in meters along y-axis. So you need to write it, mention the quantity and the axis on which you want the experimenter to label it. Yeah. So plot a graph, and then from the graph we can find the relationship between the angle of launch and the range, how it affects the range of the ball. So this is my conclusion. So you get 1 mark for that. And finally, any additional details that you want to pinpoint, you can write it here. For example, I want the experimenter to perform this experiment in a closed environment. Why? Because I don't want the wind factor to affect the experiment, right? To avoid the disturbance of wind. So that is my suggestion, my idea, my precaution for the experimenter that I am suggesting to avoid the disturbance of wind. What are the other things that I could add here? Always keep the height of the channel heights. What are the heights? H1, which is the bottom tip, height of the bottom tip from the floor. H2, which is the height of the top edge of the channel, right, from the floor. I already mentioned that in the picture, if you remember, in the diagram. So keep the heights of the channel constant throughout the experiment. Because you see, it's easy to draw it on the paper, but when you perform the experiment, it's really very difficult to maintain those heights to be always constant. So that's why I add this as another precautionary step for my experimenter throughout the experiment. So that's all about the 4 headings. Method, how you are going to perform how you want the experimenter to perform the experiment in real time, right? What are the 2-3 things that you need to mention, you should not forget in writing your method? how the independent quantities and dependent quantity are measured, right? Number 2, repeating the measurement of the independent quantity for 2 trials and finding the average. Number 3, repeat the experiment for at least 5 times to collect 5 sets of data. Yeah, and do not leave any minute points that are described in the question here. Okay, and then next heading is table. When you draw the table, it's an empty table with independent quantity in the first column and dependent quantity in the second column. You may add this one, the pre-first column here, where I have 5 sets of data mentioned, right? And third mark is for analyzing and making conclusion. So how do I analyze the data? By with the help of the graph, right? I want my experimenter to draw a graph where the independent quantity angle to be plotted on the x-axis and dependent quantity range to be plotted on the y-axis, and then I want my experimenter to find the relationship between these two from the graph, right? And any additional points or precautions you want to mention, that you can write in the final heading, subheading, which is precaution and additional details. So if you categorize your entire question into these subheadings, it will be easy for you to answer as well. Okay, all right. So for March 2022 paper, we will discuss it in the final part of the video. Thank you.